Hello everyone, my name is Rashidullah Shubho. Today I am going to describe about my DLD project. And my partner is Jahidul Pranto. Here he is.
Hello, Assalamu alaikum. I am Jahidul Pranto before you. First of all, I am going to tell about our DLD project. Our project name is a squaring system, a system which will take input and produce a square of them as output. Suppose you give input 7, that means in binary it's 111. It will give you output 110001 49 as an output, square of 7. The apparatus we used that are 9-volt battery, 3 switches and 6 LEDs and 6 1 ohm resistors and 2 AND gates, 1 NOT gates and 1 OR gates. The next part is going to be present by my project partner Mohammad Rashidul Haq Shoho in details.
Thank you Jahidul Pranto. Now I am going to describe in details about our project. A squaring system is a system which takes the input and produces a square of them as outputs. We have seen square inputs in decimal, but it is not common that we have seen square inputs in binary. Sometimes we use it for individual purpose, but most of the time we do not use it. Here is the truth table or the system that we have implemented. Here XYZ is the input and F1, F2, F3, F4, F5 and F6 are the outputs. XYZ is working as the switch where we can input 0, 0, 0 or 1, 1, 1. The 8 combinations of 0 to 7 in decimal, and we can see the outputs in the circuit in LEDs that you can see over here. 0 means the LED is off and 1 means the LED is on. For implementing the circuit, we have basically done the Karnaugh map for every equation. Here you can see some of them. And by doing the Karnaugh map, we finally got our circuit that we had been designed to implement. And finally we have got the design that we need to implement for our project. These are the components that we use for our project, and this is the pin configuration for these 4 ICs. First one was the first one. Here you can see the NOT IC and the Karnaugh map, the X and X bar, Y bar, they are the outputs that we have produced from there. You can see the individual outputs and the individual ICs. Here the middle twos are the AND ICs and the last one is the OR IC. You can see the truth table that we have used in our circuit. Here XYZ is the input and F1, F2, F3, F4, F5 and F6 are the outputs. After connecting all the ICs with wires and the switches and the LEDs with resistors, the circuit looks like this. If we want to give input in the circuit, here you can see 3 switches, 1, 2, 3. Here we can input 0, 0, 0, 0, 0, 1 from 0 to 7 basically. and we can give highest input is 111. That's the 7 in decimal, and we can see the outputs in here in the LEDs. There you can see the LEDs, 6 LEDs here, and let me show you the outputs by connecting it with the 9-volt battery. Now in the circuit, if I give you input 000, which is already given, no LED is blinking, that means the output is 0. When we are giving input 001, you can see the last LED is blinking. When we give the input 010, you can see the third one is blinking, that is 100. If we give input 011, you can see the 1001, that means 9. When we are giving input 100, you can see the second LED is blinking. And now if we give input 111, which is the last input we are giving, 111, you can see the first, second and the last LED is blinking, which is the square of 111. We have faced some difficulties that setting up the pin configuration in switch, and in LED lights we have to maintain positive negative sides. In LED lights we actually don't know what is the positive end and what is the negative end, because they were both same. So we face difficulties in producing the outputs. Sometimes we give the positive end in the negative and the negative end in the positive. We were thinking that our project, maybe we have done something wrong in our circuit, but at last we found out that the problem was not in the circuit, the problem was in maintaining the positive negative sides of the LEDs. Thank you everyone. If there is any question you want to ask regarding my project, you can comment below in the comment section. I will definitely try to answer all your questions. Thank you.